Yeah, certainly not as insane as he was. All right, so my involvement with the project was, I found out what he was doing. I thought it was pretty neat. I'm sort of going to take this in a little, slightly different direction. Um, I thought it was pretty neat the types of data he was gathering, and I thought, well, what could we, what could, like, can we glean some more information from it and stuff? Wake can we glean some more information from it? Can we get, can we get some information about like what developers in Chattanooga, what their backgrounds are, what kind of companies they work for, things like that. Um, at first, I suggested to him to publish this on GitHub or something like that, and have people sort of let loose on it. Um, but then I thought, well, as a personal challenge to myself, I have a teeny little bit of background in data science, having had somebody pay for me to go to grad school. Thank you, large insurance company that's up on the hill. Starts with a C. um, but I'm not a trained data scientist. I don't know data science that well. We had someone who wasn't a statistician, and now we have someone who's not a data scientist. What the heck are we doing up here? I don't know, but we're talking, you're listening, and it must be the free pizza. Anywho, so my intent is to sort of ask questions of the data, show how I got those questions answered, and share those answers, so we can sort of delving into data science a little bit. And the first task in data science is obviously understanding and cleaning the data. That's what data scientists spend 80 to 90% of their time doing, according to the stats, which is pretty sad, but whatever. But because I had a much smaller much smaller sample size, we had 68 surveys. 68 respondents. One got thrown out because it was just a bad respondent. It was much easier to clean the data and everything. So first thing to do is handle missing data. There's lots of ways to handle missing data. You could sort of like average out all the other respondents' responses. So if someone didn't respond to how many hours do you work or something like that, you could just sort of do an average and plop it in there. Or you could do some kind of sentinel value like -1 or something like that, showing that they didn't ask for the survey. Or you could sort of, there's a bunch of things you could do. So for example, the high school diploma question, there was one person that didn't answer that question. So there was one person that didn't answer that. Well, looking at the fact that 90% or 99% of the respondents answered they had a high school diploma, then the average for that was basically, yes, that person had a high school diploma. There was a question having to do with, is your degree related to your current job? And many of the people who answered that no, they don't have a degree, did not answer that question, is your degree related to your current job? But if they don't have a degree, then clearly their degree is not related to their current job, so you can then automatically assume that, well, you can then automatically state that that the degree is not related to their current job because they don't have a degree and things like that. Also in the survey, there was a free text box for your stack, basically what kinds of things you do, or what kind of tools you use. People would respond something like maybe OS X and OS X all put together, and had standardized that to OS X. Or people say that they write some Angular, React, Node.js, CS6, whatever it is. But these are all JavaScript frameworks, right? So if we're trying to get a comprehensive, an idea of how many people work in JavaScript kind of thing, then you sort of want to standardize all that into one. And this stuff could be done easier because it's a smaller data set. But so I could sort of do it by hand or just write little macros to do it. Whereas if I had 67,000 or 67 million responses instead of 67, it would be much harder to do. Binning, Jared mentioned that there was some sort of arbitrary collection of what company size you work with. No, you're good. What company size you work with, and I sort of just bin them into, instead of saying 200 people, 300 people, 400 people, or just sort of bin them into small, medium, large enterprise, very extra small. And I could have done at lie detection, but I chose not to. For example, there was someone who had about 180 days off, which is practically unheard of. So you could sort of term that as an outlier, but I chose not to because what if they're self-employed and they make lots of money, so they work 9 months of the year, and then the other 3 months of the year they decide to go sip pina coladas in Maui. I mean that's up to them. And we could throw that in there. So, all right, let's check her out. Can everyone see this? All right, bump it up. There we go. All right, so this is done in Python clearly, because I am not smart enough or stupid enough to use R. I'm not sure which one, but probably smart enough. So basically, read the data in, and with pandas you can sort of just do tail or head to sort of get a cursory understanding. It's familiar to anyone who uses Linux to get a cursory understanding of what the data looks like. So we got timestamp, years of experience, number of hours worked, desired number of hours worked, days off, salaries, their stack, meals. Do you want a free Tesla? Just about everybody. What key street count and all that stuff. So here's the little function to sort of bin the sizes. This is a standard for the US. If you're under 7, it's micro. If it's under 250, it's a small company, medium, large, and whatnot. And then you can sort of apply that as a lambda to that particular column in your data frame. I did a head to check it out, and now you can see that we've gone away from what was our previous, from 250, 10 and 1 and 5 to small and micro and whatnot. Then I also subjectively chose to drop columns that didn't particularly give me any insight. So things like timestamp, desired number of hours worked, free Tesla, public speaking. And now I'm just going to try to get an understanding of what the data is like. So let's try to understand the data, describe it. You can call the describe function on the pandas data frame to get what's the count, the mean, the standard deviation, the max, which is pretty neat. You get all this stuff for free. You don't actually have to do any of this yourself, as long as you know what functions and tools to use. So, right, what's interesting here is, well, clearly salary is always interesting. Minimum salary is 20,000. I pity the person. If you're 65,000, if you're from 20 to 65,000, you're in the bottom 25%. If you make 77,000, under 77,000, you're in the bottom 50%. If you make over 95,000, you're in the top 25%. And sort of the same thing applies for just about anything you can see here. So I could actually draw a histogram of this if I wanted to, but I did this last night almost. So yeah, lazy. Now on to questions. What's the most common company size, years of experience, number of jobs, number of books read, and you can pretty easily just call mode on those particularly selected columns. So the most common company size is, what was 2? 2 is small, yeah. For the respondents, most common company size is small. The most common stated years of experience is 10, which is kind of interesting. Most common work history counts were 3 and 4. The most common number of books read was 3, and the most common salary mentioned was 75K, which is kind of neat. what are the most common stack tools. To do that, first I need to sort of, because we got a bunch of, we got free text, and I need to be able to vectorize the text and so I can count those particular, each particular token. So I've got a little function here to, to, to split the free text on the semicolon, and then use the scikit-learn feature extraction to do a vectorize it, and so this gives me 161 mentioned sort of stack tools. If I take a look at what those are, we have things like .NET, Airflow, Android, Anger, baby bottles and burp cloths, CentOS, chairs, no way. I guess they don't stand while they code or do other things. C#, CSS, CSS3, whatnot. Cool stuff, go. So, I turned this into a data frame, joined it to my other data frame, and did a sum, sorted it ascending, and now we can see the most common stack mention tools: JavaScript, Linux, Node, Ruby, Rails, Postgres, Nginx, PHP, MySQL, Angular. So clearly either a very webby crowd or a very full stack, right? Because a lot of JavaScript. A lot of JavaScript makes up more than 50% of the respondents. Next up, I try to find out if there are commonalities in groups of respondents that machine learning can sniff out on our behalf. So can I take a group of respondents and say, this group of people, work at a company that's, this group of people could work, make about roughly, $60,000 to $75,000 a year. They work at small size company, and they like to read roughly they read roughly 3 or 5 books, while this other group, has this and that and this and that, these attributes. So to do that, I could do some clustering. Chose to use a basic k-means clustering algorithm, and just said, basically dumped what I had at it, and all this naked growing, to see what it would come up with. As for my first attempt. It worked, but if you notice, these are the cluster labels, so cluster 0, cluster 2, cluster 3, and whatnot. If you notice, it seems like the cluster zeros are in the sort of 70, to 90,000 range. The cluster 3s are in the low 50s, and the cluster 2s are in the 120 range. So clearly what was happening here is that salary outweighed all the other features in the clustering. And the reason for that is because salary is the biggest number out there. So, and k-means clustering is sensitive to scale. So what I need to do is to denormalize the data to sort of bring the scale down. And so that's what I did here. It's to normalize the data, to bring the scale down. So that's what I did here. So now we've got everything between 1 and 0. So you can't, except for company size, right? We've got everything between 0 and 1. So one particular feature doesn't overshadow the rest of them. And I did another cluster, and now you see. No, not. Here's the normalization algorithm right here. That's the feature minus the mean value divided by the max value minus the mean value. So it's a min-max scaling. All right, so now I've got my clusters after normalization, and they tell me absolutely nothing. Why they tell me absolutely nothing? Because there's just way too many features, too many dimensions. We've got roughly 200 different features, and so it's hard for my puny little brain to say this person was put into this cluster because they have this and 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 this, and I'm running out of limbs to count all the features that went into the decision to put this particular person into this particular cluster. So clearly, if I need to fix that, what I need to do is dimensionality reduction. And I can do that with PCA, but it gets a little hard to understand. And what I'm really going for is things that are understandable. So what I choose to do instead is just select a couple of things. To cluster on. And this works a lot better. So I've got cluster 1 who makes between 20 and 70,000. 20 and 77,000. They have between 0 to 3 days off, 0 to 30 days off, and they work between 1 and 6. They've worked at between 1 and 6 jobs, and so on and so forth. So pretty neat, pretty cool. We're running up on time, so I'm not going to take up too much of your time explaining the clusters, but it's there. It's on GitHub. You can go check it out. The last thing I said is, so what are the important features of this data set when it comes to salary, and can we predict salary based off of the features? And I chose to use a decision tree because, again, I'm going for explainability, right? With the decision tree, you get a bunch of, what you end up with is a bunch of rule sets that say something like, if you have this particular feature, and you have this particular feature, and you have this particular feature, and everything, then you should be making this particular amount. Or better interpreted, people with this feature, and this feature, and this feature, and this feature make this amount. People with this, and this, and this, and this feature make that amount. Again, a little bit of play between correlation and causation, but having a decision tree take into account multiple features versus just one feature gives you better margins of error. So here is what I've got, and I've got a nice tiny decision tree for us to all lean in and squint at. Raw. All right, so one of the things that the decision tree also does is, because it goes through recursively, goes through each and every feature in your feature set, you get to see what was taken into. We get to see what features are most important in making decisions. So now, because this is normalized data, you won't. It's hard to tell what this actually means, but and I had a sheet where I translated, but I forgot to bring that, where I basically min-max scaled it to the actual data. But if you have years of experience less than, I believe that number was 8, then books read comes into account. And if you've read less than 1.5 books, which means 1 or 0, then whether you have a 401k comes into account. And if you do have a 401k, then you'll be making this amount. And again, I could tell you what this amount is, but I didn't actually finish this because it was done last night. But three people who have these particular characteristics made X amount, let's say 70,000, which is pretty neat, right? You can then predict that if you've got all these things, you expect to make this X amount. If you don't have a 401k, then it's one of these two amounts. If your days off, if you've read more than that, then days off comes into play. Days off becomes a more important feature in predicting what your earning power is. If you do have more than 8 years of experience, then do you have a degree? If you have a degree, it's going to take a look at your years of experience again, and it's going to take a look at your years of experience again, and this time the user experience is, if I remember that correctly, that was 10. And it's going to look at, if it's less than 10, then it looks at the number of books you've read and the number of hours you worked. It's pretty cool. I should have the numbers to translate it, but I don't. I apologize. But what's neat about it is you can then see what factors really speak to what your earning power is and things like that. Again, disclaimer, this is closer to correlation than causation, but it's certainly and I didn't have a large enough sample size to be able to, divide it into a training and a test set, a test and a training set and a proof set and everything. So I don't have the numbers for the margin of error, but it's, here it is, and maybe we can get more data to do that later. So that's what I've got. And Jared is gonna sort of come clean up here if we've got this right here. Yep, the end.
Thanks, Dan.